Hello friends, in this video we will talk about throttling. We will talk what is throttling and how you can implement that in JavaScript. So let's see what is throttling. So in computer science, throttling is used to restrict some operation triggered by some event. Clumsy definition, let's see. So let's say you have triggered some event. Now this event can be triggered by a user, right, or by a web service, or something happened. Let's say you uploaded a file, right, or you change the screen size through your mouse. So anything the user triggered, or it can be computer triggered or some web service triggered, right? If this event, when you have done this operation, right, this event basically, then it will do something, some operation. When I say operation, it means it may be doing it may be running some logic when user has, let's say, resizing the window, or some web service has uploaded an image, right? Then let's say we have to remove some artifacts from that particular image, or we have to resize that image to some particular dimension. Some logic will be running, right, based on this event. So let's say now you are triggering this event multiple times, let's say in 1 minute 1000 times, right? Then each time if this operation is done, it will consume some resource, right, because it has some logic. For example, you have a window, you pick this particular side and dragging here and here, right, through mouse. Then it will resize this window, right, first small and then bigger. Or another thing which I am saying here, let's say you uploaded image on the backend server, right, uploaded your image. Now this image will be uploaded in let's say S3 or some database, whatever. This will trigger in function. Here function means another API will be called, and this API can be of some server or serverless. Then, and this image when uploaded here, right, and the operation here could be resize this image. Let's say this is of 1 GB, make it the smaller in KBs, something like this, right, or change the dimension number of pixels. So that is the operation. In this type of use case you might have seen in some websites where you call that you upload your image basically to that particular website, and it will return a resized image, right? So in this case, when you implement that type of system, the operation will be triggered, right? It will run some logic, and when this logic is there, it will have some basically CPU cycles will run, right? It will have some cost. When I say cost, like it is taking some time, right, or some memory. So the server is basically consuming some resources. It means it is burning some resource, some cost for that. But in this case, if you are uploading, let's say, thousands of images, if it will trigger of basically this logic again and again, then this service can be down, right? Or for example, if you are resizing your window on your laptop, right, very fast, then it will hang your machine, because it is doing a lot of calculation while drawing this again and again, this particular window, right? So what happens to reduce this type of behavior of hanging in such cases, or bringing the whole server down? We use the concept of throttling, right? Now in this process, what happens, we don't trigger this operation each time unless until it is happening after let's say some few milliseconds or seconds. For example, here you are uploading an image, let's say every 10 milliseconds. Then this will not upload, or this will not trigger the logic, this one, then there, because thousands of requests will come to this server and it will go down. So without to avoid the crashing of this server, what we can do here, we can put the throttling logic. And by the way, all the websites do this throttling, especially like Google or Microsoft, Facebook, whatever systems that we have, bigger systems, so definitely will make sure the throttling happens if some user is misusing the system. And similarly here on Windows, let's say if you are triggering this faster, changing this size of your window, then it will not redraw that image in your window. It will take some time. Let's say after few 100 milliseconds, if there is one request, it will draw, else it will not draw. So consider scenario, you have a window, right? Something is there, that window. Now you pick this corner and increased it. So this size would be there, right? It will expand. And if you do further, then it will expand further. Now in this case, you are doing slowly, then it will resize this window and you will see a proper window. But if you are doing very fast, then in that case, what happens? It will not pick all the request basically at every millisecond, let's say, but it will pick only after 100 milliseconds. So if you have done, let's say, 100 times, though you are not that much of fast as a human, but let's say some machine is there, then it may make those changes very fast. So in that case, your resizing and redrawing will not happen even after every millisecond, but it will happen 100 milliseconds. And this 100 times that I have picked, but based on the system and the use case, we can pick this. So this is the concept of throttling. But let's say in JavaScript, if I tell you implement it, how will you implement it? Let's see the code. So before writing code, let's understand what we have to do. I have a function which will do some operation, right? Now to run that operation, I need user will be called only after that function with some delay, right? So what I will do, I will create a wrapper function, right? And where this wrapper will contain a logic, right? This is the logic, operation logic, and let's say this is the wrapper. And in this wrapper function, we will handle that particular delay. And yeah, so basically that particular delay, if some request is coming before this delay, then that particular request will be ignored. Okay, so let's go and see the code. So let's say we have a function which is called throttle, and this throttle function will take an argument as a function, which is this operation, right? And it will take some delay. Now we have to write the definition for this. So what will happen? Let's write this. We have to return a function, right? Again, so we will do a return, and return, let's say we are using an arrow function. And in this function, what we will do, we will basically return this function, but with some delay. So we have to call first this function, and when we call this function, why we have to call first? We don't have to delay, wait for some time, but after this function we have to wait. So let's say this function may take some argument, and these arguments can be passed if this function, let's say, has some arguments args, and okay, we have to bind the context also, right? So we will call apply function dot apply. This is a reference of this particular object, and then we can pass args. Now this function will be called. Now we have to delay, so we will call set timeout. In timeout, what we have to do, we will run some logic, right? And let's say I am adding an empty function. I'll talk about the logic later. And this delay, right? We have to do this. So what this function is doing basically, now we are taking a function as an argument and delay, and then we are returning a function which is taking some arguments. We are applying those arguments to the given function, apply function dot apply this, binding the context and argument, and then we are waiting for this much of time, and we are not running any logic, but it will just return, right? So but let's say if someone calls this function again, then we are not, it will be called, right? We are not waiting actually. So this logic will run only if your basically yeah, so this logic should run only if some variable we have to set, if it is true, and that variable will give the value if this function is called within some point of time. So let's take this variable as t, okay, t basically the time, the last time, and this is equal to not time, actually the only the value true. This is actually false. Okay, let's take it false. Now if this is equal to true, then only we will return this. Otherwise we'll just simply return if t equal to true, right? Then only then we'll just return right? And else we will return this. So till this point, the logic is clear, right? What we are doing, we have taken a variable called taken a false, and this t is saying that in the last time we have called already this function. We will set, if we have called this function, we will set this equal to true. So here we have already called, now we are making this true. Now we have made what? True. So the first time when this function will call, t is false, so this condition will not trigger, it will return this function. And this in this function, when it return, it will run this, actually this particular function, and then it will set t equal to true, and then it will wait for some time. Now let's say before this much of time, right, another call will come. What will happen? t's value is true, so it will return from here, right? Now you might be wondering, this is a local variable, but what happens, this here the concept of closure will come. So in the concept of closure, you might have seen, when we are returning this function, it will take these variables together because of the concept of closure. So t value will remain true till when the second call came, right? Now what somewhere we have to set this false also. So you might have guessed where that t equal to false should come. Think, yeah, here, right, in this set timeout. So we have to call t equal to false, which means now we are saying the timer is done after this much of time. If any request comes now, the t value will be false, so this logic will not run, and it will basically run this function. So when we use this function, let's say you have a function called let's take a very simple function, let's say called a driver function, right, which is, and what it is doing, it is just doing console log, let's say a, very simple function, a driver function which is doing console log. Now if we want to make this function as a throttled function, what we can do, we can use this function. So let's say x, let now throttle, we will take this driver function, and let's say delay is 100 milliseconds. Okay, now if you call this x, what will happen? You are basically calling this wrapper function where t is set to false for the first time, and when this logic will run, it will basically run your driver function, this particular, right, function, and it will print, and this is containing some logic which will take more than 100 milliseconds. Let's say it takes 1 second complete, right? Now for the 100 milliseconds, no new request will be taken for driver for printing this. So in before delay of the 100 millisecond and the request comes, then what will happen? In this logic, it will check. So here, so this here we have this particular thing. I'm sorry. Here this statement should be here. If t equal to true, then just return. Else it will do this, right? So here t equal to false. So in the first run, t is false. So this statement will not execute, but function will be called, t will be set to true, and set timeout. If within those 100 milliseconds and the request comes, t is still true by the effect of this statement, right? So it will just return. Let's say after 100 millisecond, first 100 millisecond, a request comes, t will be false. Why? Because of this set timeout, this particular function. Here the concept of closure play a role because this local variable is there, but the value will be available here in this function as well. So I hope you got the idea of throttle, what is throttling in computer science, and we have seen the examples of the API, or we have seen the example one of on Windows machine, let's say we are doing, or some any operating system. We have seen the code of that, and we have seen a code why it is running in spite of this local variable, because of the closure concept. If you don't understand the closure concept, I have another video which I created. I'll put the link of that video in the description below. So with this, please like this video and share with your friends. click on the like button so that it will be, it can reach to other students as well. Please subscribe to this channel. This will help this channel to grow and reach to other potential students. With this note, this is BK from Maneka signing off.